a quick overview of solving quadratic equations by graphing. Whenever you are graphing quadratics, there are three possible outcomes. We say that this could have one solution, two solutions, or zero solutions. So before we jump into what our answer is, we need to talk about what are solutions. So a solution, or a root, or a zero, all saying the same thing, three different ways saying the same thing, is where the graph crosses the x-axis, aka the x-intercept. So because of the nature of the graph of a quadratic, we have three potential outcomes. One solution would be a situation where the vertex of the parabola lies directly on the x-axis. Two solutions would be if your parabola has been transformed or shifted in such a way that it's going to cross the x-axis in two places. Or it could be the case that you have no solution based on the way your graph is oriented. So in this case, if I went up and then I'm opening up as far as my parabola, then I would have no solutions because I never crossed the x-axis. So to solve by graphing, just to keep it as simple as we can, we covered graphing last class period. So of course you can solve using negative b over 2a. We can find the x coordinate, which is also the axis of symmetry. We could then get our y coordinate of the vertex and do some detective work that way. But for today, we can also just go to Desmos, put in our equation, and check the graph. So what you'll be looking for today would be the values of x that are going to correspond with your x-intercepts. Or another way of thinking of it, what values of x make the equation equal to 0? So that's why we call them our zeros or our roots. We'll look at algebraic ways to solve for these next class, but for today we're focusing on the graphing aspect. So this is an example of two solutions, negative 3 and 2 in no particular order. If you wrote 2 and negative 3, that would be fine as well. Example 2, we've pulled a problem where you're going to have that one solution scenario. So when you go to graph this little guy, you'll see that its vertex is at negative 2. That counts as a root, but it only has the one since it doesn't actually cross and pass through the axis. It just has that one solution. And of course, just putting some numbers to it with a real life problem, this is an example of no solution. Our vertex is shifted up and then our parabola opens away from the x-axis, so it will never cross.